Hi, Math 2. So this video should be kind of a review of the different factoring patterns that we've learned about. So for number 1, it says multiply the following. So here what we're doing is we're multiplying two binomials. So we're going to use what's called foiling, right? We're going to do our first term, we get x squared. Our outer terms, we get negative 5x. Our inner terms, we get plus 5x. And our last terms, we get a minus 25. So these two middle terms drop out and we get x squared minus 25. All right, so I want you to go ahead, try this one. FOIL it out, combine like terms. So when I did this, I got 4x squared minus 9. All right, try this one. You should get x squared minus 81. Now it says factor the following expressions. So notice, right? Hopefully now this is kind of reminding you of something we've already done, right? This is that difference of two squares, right? So if you recall, we do a plus b, a minus b. X plus 7, x minus 7. Try this one. Should be a review, right? You should get 9x minus 2, 9x plus 2. This one's a little bit tricky. First, you need to factor the 2 out, right? You should always look for greatest common factor. All right, then you get 2 times x minus 6, x plus 6. So this is following that difference of two squares pattern that we've already learned about. All right, so we call this pattern difference of two squares. All right, so hopefully that was kind of a review of difference of two squares. Hopefully by now you feel comfortable working with those kinds of problems. All right, so let's go ahead and try this next one. So if you recall, the first thing we should look for is a greatest common factor. All right, so look here. I can take a 3 out. I get x squared plus 6x plus 8. All right, and then I have to see if I can factor this trinomial further. So I got to figure out what multiplies to give me an 8 and is going to add to give me a 6. So that's going to be 4 and 2. And that would be our answer there. All right. Let's go ahead and try this one. All right. We're going to see if there's a greatest common factor we can take out. I see I can take out a 2. So I get 3x squared minus 4x minus 7. So now we got to figure out what multiplies to give us a... Oh, actually, we have to figure out what multiplies to give us negative 21. Right, and it's going to add to give us a negative 4. So it's going to be negative 7 and positive 3. So we get 3x minus 7, 3x plus 3. Got to take out our greatest common factor because we had to multiply, right? X plus 1. So that would be your answer there. All right, I want you to go ahead and try this one out. So let's go ahead. We're going to factor out a 4. So you get x squared plus 2x minus 48. All right, so we got to write out factors of negative 48, right? We need to factor this trinomial. There's no leading coefficient, so we're just trying to get a negative 48. So I would say a good bet here would be positive 8 and negative 6, because that's going to add to give us our positive 2 in the middle. So we're just going to do 4 times x plus 8, x minus 6. We don't have to take out a greatest common factor because there was no leading coefficient on that trinomial. So we're good there. All right, try this one out. So for this one, we're going to see if we could take out a greatest common factor, which in this case would be 3. So we get 9x squared minus 1. And then this is a difference of two squares. So you're going to get 3x plus 1, 3x minus 1. All right. Next one. We got to see if we can factor this guy. So first, let's look for a greatest common factor. So looking here, I would take out a 5. So I get 4x squared minus 225. This looks like a difference of two squares. So I can take the square root of both of these, right? I get 2x and I get 15. So I'm going to do 5 times 2x plus 15, 2x minus 15. All right. And that would be our answer there. Now for this one, you got to take out a greatest common factor. All right. So looking here, my greatest common factor is going to be a negative 2. Now, why am I taking the negative out? Because the negative is on the highest power. So I'm going to get x squared minus 3x plus 5. Then I look and see if I can factor this further. So I have to look at factors of 5. 5 is prime, so the only factors you have are 1 and 5, or you could do -1 and -5. Neither of those are going to add up to give you that -3. So this actually would stop right there. All right, so let's go ahead and try this one. So it says multiply each using the area model. So again here, if you decide to just do foiling, right, where you distribute each term, I'm fine with that. You don't have to use the area model, but I guess it's good to know how to use the area model. So go ahead, try it out, multiply out this binomial. So when I did this, we got 3x, 8x, and 5. We get 3x squared, 15x, 8x, and 40. So we're going to combine like terms. We get 3x squared. We're going to combine these two guys. So we get plus 23x, and we get plus 40 at the end. Now, for this one, I'll go ahead and do this one. We're going to use the area model. We get 5x minus 2, x plus 7, 5x squared, 35x, minus 2x, and minus 14. So we're going to combine our like terms. So we get 5x squared plus 33x minus 14. And that would be your answer there. All right, so now for number 5, it tells you to factor. So we're going to go ahead and use that method that we used earlier, where we first check to see if there's any greatest common factor we can pull out. We cannot, so we're going to multiply the first and the last number. So we get 140. All right, so that's kind of a big number, right? So we're going to go ahead and find some factors of 140, all right, that might work. So looking at this, let's go ahead, maybe do 140 divided by 35. All right, that gives us 35 and 4. So 35 plus 4 is going to add up to give us our 39. Are there other factors you could have written down? Yes, but this is the one that's going to work. You also could add maybe like 14 and 10, 2 and 70. There's a lot of other factors, but the 35 and 4 is what's going to work for you. So we're going to go ahead, write it out like I showed you. So we get 7x plus 4. Oh, I'm sorry, that's 7x plus 4, my goodness. 7x plus 4, and 7x plus 35. Right, and then we got to take out our greatest common factor, which here is going to be a 7. So we get 7x plus 4 and x plus 5. All right, and we can go ahead and write that in our boxes to check. So we get 7x and 4, x and 5, and make sure it works, right? We get 7x squared, 35x, 4x, and 20. All right, and our middle terms do add up to our 39, so it checks out. So this would be our factored form. All right, now go ahead, try to figure this one out. It's going to take you a little bit of time, but see if you can work it out. All right. So for this one, we're going to do 27 times 4. First, you look to see if there's a greatest common factor. There isn't. So you get 108. All right. So let's do 108. We could do, let's see, we want a 39. So let's write out some factors of 108. We could do 1 and 108. And we know that they're going to have to both be negative because we're trying to add to a negative there, right? We can do 2. We get 54 and 2. All right. 108 divided by 3 gives us a 36 and a 3. So we get negative 36 and negative 3. And this guy's looking pretty good. That's going to add to give us our negative 39. So we're going to use our negative 36 and our negative 3. So we get 4x minus 36, 4x minus 3. And we're going to take a 4 out of here. We get x minus 9 and 4x minus 3. And we can go ahead and write that in. We get x and 9, or negative 9. And then a 4x and a negative 3, right? So we get 4x squared minus 36x minus 3x and plus 27. So these guys add to give us our negative 39. So this is going to check out as our answer. All right. So notice factoring the quadratic expression will be more challenging when, and that would be when when you have a greater than 1, right? When your a does not equal 1, things become more challenging. All right. All right, so let's go ahead and try these out. I want you guys to give these a shot. I know you know how to do these, so try and do A. All right, so when I did A, I did 5 times 8. That's going to give me 40. All right, and then 2 numbers. I'm looking for 2 numbers that are going to add to give me 22. So it looks like 2 and 20 are going to be some good choices here. We get 5x squared plus 2. Oh, I'm sorry, 5x plus 2. And then 5x plus 20. We're going to take a 5 out of this guy, so we get 5x plus 2 and x plus 4. So that would be our answer there. We could always check. 5x and x gives us our x squared, right? So we're good to go. All right, let's try B. Go ahead and try it. So we're going to do 3 times negative 6 gives us negative 18. So I would say negative 18, or I'm sorry, positive 18 and negative 1. That's going to work there, right? So we've got 3x minus 1, 3x plus 18, and we can take a 3 out of here. And again, we can check our answer by multiplying our first 2 numbers. We get 3x, and x is going to give us our 3x squared. So we're looking pretty good. We factored out enough here. All right, and I'll do the last one for you guys, right? So we're going to do 4 times 4 times 21 is going to give us 84. All right, and then we can write out some factors of 84. We want to figure out ones that add up to negative 20. And thinking about it, I think negative 14 and negative 6 are going to be some good factors there. So you get 4x minus 14, 4x minus 6. We end up with 2x minus 7 and 2x minus 3. So that would be our answer there.